Elasticity. Elasticity is the ratio of change of demand based on price. So think about it. If you want to buy something and it costs $1, you might be more inclined to buy it. But then if it costs $3 or $5 or $10, you might think about it a little bit longer. So the ratio of change of demand based on price is what we call elasticity. So let's try this. We have a couple different elasticity equations and we'll look at those as we use them down through. So let's look at number 5. The demand function for a particular pair of sunglasses is this. If the sunglasses are priced at $65, how many pairs can be sold? So basically it's asking us what is the demand if the price is $65. So if the price is $65, how many are sold? So we have our function. We have P equals 155 minus 0.035Q. So 65 is our price, our P. So 65 is equal to 155 minus 0.035Q. So let's solve it down. Subtract the 155 from both sides, and that'll give us negative 90 is equal to negative 0.035Q. Divide both sides by that negative 0.035, and we get 2571.43. So this means that about 2,571 pairs of these sunglasses will be sold at $65 per pair. I rounded it to a whole number of sunglasses just for the rounding here, but that's our conclusion. It looks like 2,571 will be sold if they cost $65 per pair. So let's try the next part. Part B, compute the elasticity of demand when the sunglasses are priced at $65 and interpret your result. At this price, is the demand elastic or inelastic? So let's see if we can figure this out. So we have some elasticity formulas that we need. So let's write those down, and those are from the top right, here. So the first one that we're going to start with is this one right here, our E of Q. So let's try that one. So we have E of Q, which is our elasticity, equals the opposite of P divided by Q, all over dP dQ. So in order to figure this out, we're going to need to use our information that we solved and fill in all of our different pieces. So here's what we have that we've already solved. There we go. Well, I don't have a dP dQ. I have a P, I have a Q. I can fill those in, but I don't have dP dQ. So let's see if we can figure out dP dQ. So what would dP dQ look like? Well, let's go back to our original function. So we have P equals 155 minus 0.035Q. So if we take the derivative of this, that would give us dP dQ. Well, the derivative of 155 is 0, and the derivative of negative 0.035Q is negative 0.035. So now we have all the pieces that we need. So let's fill them all in. So E of Q equals the opposite of P. Well, we found P at 65, so negative 65 over Q. We found Q. Q was our 2,571. And I'll stick with the whole number rounding because it's the sunglasses and I can't sell 0.43 of a sunglass. So 2571 is what we'll stick with. All over our dp dq, which we found was negative 0.035. So now we need to put all this into the calculator. Remember, this will be over 1. So it will look like E of Q equals negative 65 divided by 2571 times 1 over negative 0.035. So if you put all that into the calculator and solve it down, you should get 0.722, and that will go to 72%, 72.2%. So when we solve this down right here, this E of Q, which was E of 2571, right here is less than 1. See? It's 0.722. So we have less than 1. So if we go back up to our table at the top right here, our E of Q is less than 1, which means it's inelastic, which means that the revenue is what you're looking at. Then the revenue increases if prices are raised, which decreases the demand. So what that means is you don't have to produce as many, but you get more for each one that you do produce, and you actually will have increased revenue. So it goes back to the question of, is it better to make more and sell them for less with an increased demand, or is it better to make a few less and sell them for a little bit more, but that would decrease your demand? In this case, if we want revenue to increase, well, our revenue will increase if prices are raised and demand decreases. So then we can use this comparison right here to figure out that this one is inelastic. Let's try again. An equation relating demand Q and price P is given. Compute the elasticity of demand for the given price. Is the demand elastic or inelastic? So let's try this one, part A. So when we look at this one, we need to figure out our dP by dQ. So if we solve this down, well, let's see here. We need dP dQ. How can we figure that out? Well, I don't have P equals, but can I make P equals? I have 125, 1.25 P plus Q equals 860. If I were to subtract my Q from both sides, and divide both sides by the 1.25, now I have the P. And if I simplify it even more, 860 divided by 1.25 is 688. So minus Q over 1.25. Okay, now I can take a derivative. So the derivative of our P would be, well, the derivative of 688 is 0, and the derivative of negative Q over 125 is just negative 1 over 125, 1.25. Do I have a P? I sure do. I know that P is equal to 225. And if P is equal to 225, I can use that to find Q, because I know that 1.25 times P plus Q is equal to 860. Well, 1.25 times 222 is 281.25 plus Q is equal to 860. Subtract our 281.25 from both sides, and we get 578.75. Well, now I've got everything I need. I have all the different pieces, so all I need to do now is put them all together. So we know that E of Q is equal to the opposite of P over Q divided by dP dQ. Well, we can fill all that in now. The opposite of P gives us negative 225 divided by 578.25 all over negative 1 over 1.25. So we need to do our flip and multiply. So if you take your denominator right here and you flip and multiply, And then you can simplify it down. We get E of Q is equal to 0.481. So it's asking us, is the demand elastic or inelastic? Well, again, we have our E of Q in this case is less than 1, so it means that it's inelastic. Let's try one more, part B. So we need to figure out our different pieces. If we solve this for P, so it looks like we have our 61 right here. And we need to divide that by E to the 0.4Q. All right, so now I have P. So if I need dP dQ, that means I need to take the derivative of this. Well, this is a quotient rule. So we do the bottom times the derivative of the top minus the top times the derivative of the bottom. And then don't forget your chain rule. All over the bottom squared. We can simplify this a bit. This all goes to 0. And if we look right here, this will cancel with the squared. So that means that dP dQ will equal negative 61 times 0.4. That'll give us negative 24.4. And that's all over E to the 0.4Q. All right, let's see here. Do we have everything else that we need? Well, we have P is equal to 14, but we don't have a Q. So let's put that in and see if we can find our Q. So P is equal to 14. So we'll have 14 E to the 0.4Q is equal to 61. So we need to solve this down. So we'll divide both sides by 14. So E to the 0.4Q is equal to 4.357. So we'll need our natural log to get rid of the E. The natural log and the E will cancel. So now we have 0.4Q is equal to 1.472, which means Q is equal to 3.68 when we divide both sides by the 0.4. Okay, we're running out of space, but we got it. So here we have E of Q. And we know that E of Q is equal to the opposite of P over Q, all over dP dQ. So let's fill it all in. The opposite of P, that's going to give us negative 14. And then Q is 3.68. And dP dQ is negative 24.4 all over E to the 0.4. Now it's times Q, so that's our 3.68. So we need to do our flip and multiply, and we need to substitute back in. So when we do our flip and multiply, and we substitute everything back in, this should work out to be 0.68, which means again, we have E of Q is less than 1. So that means that it is inelastic.